Hey everyone, it's Dr. Garner here. In this video we're going to take a look at the structure of the periodic table and see some of the things that we can learn from the elements based on their locations on the periodic table. This first slide that I'm showing is just a biological view of the periodic table. We have the different elements here shaded according to their roles in living systems. The elements that are shown in dark red, such as hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur, are highly abundant in living systems. They make up the bulk of the mass of most living organisms. So they're the atoms that form covalent bonds, or the atoms that form the bonds that make up living systems. The elements that are shaded here in this light gray color, they're also found pretty commonly in living systems, but they only exist as monatomic ions typically. They're not usually involved in making bonds, but they're still present. The other elements that I'm showing here that are in light red, these are elements that occur in nature. They have some natural biological roles, but those roles tend to be highly specialized. And because of that, they aren't needed in large quantities, so you will tend to only find them in trace amounts in most living systems. Everything that's shown in white has no known biological role, but that's not to say that they can't interact with living organisms. So a lot of these elements are maybe toxic, they might interact with cells in different ways, and they might have uses in terms of medicine or in terms of studying biology. So even though they don't have any natural biological roles, they can still be useful in understanding medicine and other applied fields of biology. All right, so I want to take a look at what we can learn about atoms based on where they are on the periodic table. One of the features that you can learn pretty quickly from a location or from an element's location on the periodic table is whether it's a metal or a nonmetal. So metals tend to exist as solids at room temperature. They're usually shiny and malleable, right? So these are familiar properties of metals. And they also tend to be good conductors of both heat and electricity. So the metals on the periodic table are all found on the left side of the periodic table, and you can see this kind of diagonal line that divides the metals from the nonmetals. So all of our metals on the periodic table are shaded here in orange. The two rows below the periodic table, which I didn't show on this diagram, all of those elements are metals as well. So in contrast to this, some of the elements are nonmetals. So nonmetals are a little harder to pin down in terms of their properties. Some of them are solids, some are liquids, some are gas at room temperature, so they vary in terms of their physical states. They also vary in terms of their properties. They can be hard, like diamond, for example, is quite hard. Others are soft, like sulfur, which is fairly soft. But they do tend to be poor conductors of both heat and electricity, so that's pretty typical of most nonmetals. So the metals are on the right side, or sorry, the nonmetals are on the right side of the periodic table. On this diagram, they're shaded here in green. I also want to point out that hydrogen, even though it's on the left side of the periodic table, is a nonmetal as well. So it's kind of the one exception to this trend. So everything to the right of this line is a nonmetal, everything to the left is a metal. What you'll notice as well is that there are a few elements that kind of straddle this line. So these elements are known as metalloids. So they have properties that are kind of somewhere in between that of a metal and a nonmetal. So these elements that are shown here in brown, these are what we call metalloids. All right, so the periodic table organizes the elements according to some key properties that relate to them. So the rows in the periodic table are called periods. So each row is known as one period of the periodic table. As we're going to see in the next video, these rows correspond to the electron shells. So they tell you something about how the electrons are organized within an atom. The columns in the periodic table are known as either groups or families. You'll hear it described in both ways. So each vertical column represents one group of elements. And elements that are in the same family, in the same column, they tend to have similar properties. And because of this, some of these columns are given common names that you'll sometimes hear used. For example, the first column, column 1, is known as the alkali metals. So elements like lithium, sodium, potassium, rubidium, and cesium that exist in this column are known as alkali metals. Hydrogen, even though it's in column 1, is not an alkali metal, so I would not refer to it as one. The next column, column 2, these are known as the alkaline earth metals. So these are things like beryllium, magnesium, calcium, strontium, barium, and so on. So these are the alkaline earth metals. Here in the middle, this middle block, these are known as the transition metals. So there are a number of familiar metals that exist in this region, such as iron, copper, silver, and gold are all examples of transition metals. Over here on the right, we have column 7, which contains the halogens. So halogens are things like fluorine, chlorine, bromine, and iodine. The last column to the right, column 8, these are the noble gases. So these are things like neon, helium, argon, krypton, xenon, and radon. So elements in the same column, they tend to have similar properties, and because of this, we give them common names like this. You'll often hear these names used. The columns in here, they have names too, but they don't tend to come up as often, so we're not going to worry about those in this course.